Indifference curves. Suppose we ask Lisa to identify all the bundles that give her the same amount of pleasure as consuming bundle E. In figure 3.1, panel B, we use her answers to draw a curve, capital I superscript 1, through all bundles she likes as much as she likes E. Curve, capital I superscript 1, is an indifference curve, the set of all bundles of goods that a consumer views as being equally desirable. Indifference curve, capital I superscript 1, includes bundles C, E, and A, so Lisa is indifferent about consuming bundles C, E, and A. From this indifference curve, we also know that Lisa prefers E of 25 pizzas and 15 burritos to B of 30 pizzas and 10 burritos. How do we know that? Bundle B lies below and to the left of bundle A, so bundle A is preferred to bundle B according to the more is better property. Both bundles A and E are on indifference curve capital I superscript 1, so Lisa likes bundle E as much as bundle A. Because Lisa is indifferent between E and A, and she prefers A to B, she must prefer E to B by transitivity. If we asked Lisa many questions, we could, in principle, draw an entire set of indifference curves through every possible bundle of burritos and pizza. Lisa's preferences are summarized in an indifference map, or preference map, which is a complete set of indifference curves that summarize a consumer's tastes. It is referred to as a map because it uses the same principle as a topographical or contour map, in which each line shows all points with the same height or elevation. Each indifference curve in an indifference map consists of bundles of goods that provide the same utility or well-being for a consumer, but the level of well-being differs from one curve to another. Panel C of figure 3.1 shows three of Lisa's indifference curves, capital I superscript 1, capital I superscript 2, and capital I superscript 3. The indifference curves are parallel in the figure, but they need not be. Given our assumptions, all indifference curve maps must have 5 important properties. 1. Bundles on indifference curves farther from the origin are preferred to those on indifference curves closer to the origin. 2. There is an indifference curve through every possible bundle. 3. Indifference curves cannot cross. 4. Indifference curves slope downward. Indifference curves, and number 5, indifference curves cannot be thick. First, we show that bundles on indifference curves farther from the origin are preferred to those on indifference curves closer to the origin. Because of the more is better property, Lisa prefers bundle F to bundle E and panel C because of figure 3.1. She is indifferent among all the bundles on indifference curve capital I superscript 3 and bundle F, just as she is indifferent among all the bundles such as bundle C on indifference curve capital I superscript 2 and bundle E. By the transitivity property, she prefers bundle F to bundle E, which she likes as much as bundle C, so she prefers bundle F to bundle C. Using this type of reasoning, she prefers all bundles on capital I superscript 3 to all bundles on capital I superscript 2. Second, we show that there is an indifference curve through every possible bundle as a consequence of the completeness property. The consumer can compare any bundle to another bundle. Compared to a given bundle, some bundles are preferred, some are enjoyed equally, and some are inferior. Connecting the bundles that give the same pleasure produces an indifference curve that includes the given bundle. Third, we show that indifference curves cannot cross. If two indifference curves did cross, the bundle at the point of intersection would be on both indifference curves. But a given bundle cannot be on two indifference curves. Suppose that two indifference curves crossed a bundle E in panel A of figure 3.2. Because bundles E and A lie on the same indifference curve, capital I superscript 1, Lisa is indifferent between E and A. Similarly, she is indifferent between E and B because both are on I sub 2. By transitivity, if Lisa is indifferent between E and A, and she is indifferent between E and B, she must be indifferent between A and B. But that's impossible. Bundle B is above and to the right of bundle A, which means it contains more of both goods. Thus, Lisa must prefer B to A according to the more is better property, because preferences are transitive and consumers prefer more to less. Indifference curves cannot cross. Fourth, we show that indifference curves must be downward sloping. Suppose, to the contrary, that an indifference curve sloped upward, as in panel B of figure 3.2. The consumer is indifferent between bundles A and B because both lie on the same indifference curve, capital I. But if the consumer prefers B to A, by the more is better property, bundle A lies strictly below and to the left of bundle B. Because of this contradiction, the consumer cannot both be indifferent between A and B and strictly prefer B to A. Indifference curves cannot be upward sloping. For example, if Lisa views pizza and burritos as goods, she cannot be indifferent between a bundle of one pizza and one burrito and another bundle with two of each. Figure 3.2, impossible indifference curves. Panel A. Suppose that the indifference curves cross at bundle E. Lisa is indifferent between E and A on indifference curve capital I superscript 0 and between E and B on capital I superscript 1. If Lisa is indifferent between E and A and she is indifferent between E and B, she must be indifferent between A and B due to transitivity. But B has more of both pizzas and burritos than A, so she must prefer B to A. Because of this contradiction, indifference curves cannot cross. Panel B. Suppose that indifference curve capital I slopes upward. The consumer is indifferent between B and A because they lie on capital I, but prefers B to A by the more is better assumption. Because of this contradiction, indifference curves cannot be upward sloping. Panel C. Suppose that indifference curve capital I is thick enough to contain both A and B. The consumer is indifferent between capital A and B because both are on capital I. However, the consumer prefers B to A by the more is better assumption because B lies above and to the right of capital A. Because of this contradiction, indifference curves cannot be thick. Panel A, crossing Q sub 2, vertical axis Q sub A, horizontal axis. There's a blue indifference curve, downward sloping, that holds point E and A, indifference curve capital I superscript 0, and then there is a pink intersecting indifference curve capital I superscript 1 that holds points B and E. Panel B is upward sloping, same axes as the previous panel. It's an upward sloping capital I indifference curve with A and B on the curve. Panel C is thick, indifference curve capital I. It's a thick red line, downward sloping. It has points A and B. Axes are the same as Q sub 2 on the vertical axis, burritos per semester, and Q sub 1 on the horizontal axis with pizzas per semester. Solved problem 3.1. Can indifference curves be thick? Answer. Draw an indifference curve that is at least 2 bundles thick and show that a preference property is violated. Panel C, figure 3.2 shows a thick indifference curve, capital I, with 2 bundles, A and B, identified. Bundle B lies above and to the right of A. Bundle B has more of both burritos and pizzas. Thus, because of the more is better property, bundle B must be strictly preferred to bundle A, but the consumer must be indifferent between A and B because both bundles are on the same indifference curve, because both relationships between A and B cannot be true. There is a contradiction. Consequently, indifference curves cannot be thick. We illustrate this point by drawing indifference curves with very thin lines in our figures.